Hello and welcome. You're listening to the fortnightly podcast of the University of Queensland's Astrophysics group, where we broadcast up-to-the-minute astronomical news and research happening both within the group here at UQ and abroad. For more information, visit our website at smp.uq.edu.au, or for all other inquiries, send us an email to astrogroup@uq.edu.au. Today, we're very privileged to have Dr. Jonathan Gardner, who is visiting from NASA and is the Deputy Senior Project Scientist of the James Webb Space Telescope. Let's hear what he has to say about the successor to the Hubble Space Telescope and why astronomers all over the world are excited about this next generation observatory.
Okay, so the James Webb Space Telescope is the successor to the Hubble Space Telescope. We're in the process of building it right now, and it will launch in 5 years or so. It is going to be different from Hubble in a couple of different ways. First of all, it's a bigger telescope. Bigger telescope means it gathers more light and can see fainter things. In addition, it's going to be an infrared telescope, whereas Hubble works in the visible light primarily. We do that because the expansion of the universe stretches out the light from the most distant galaxies and stars that we want to see, and that expansion of the universe stretches the light so it moves from the visible light into the infrared. With Hubble, when we take the faintest picture that has ever been taken, the Hubble Ultra Deep Field, we can get back to about 1 billion years after the Big Bang, maybe a little bit further, but we see the galaxies there at this very early time are not the first galaxies that formed in the early universe. So in order to do that, we had to see those galaxies, we have to go beyond what Hubble is capable of doing. So the James Webb Space Telescope will be a 6.5 meter telescope. In comparison, Hubble is 2.4 meters in diameter for its primary mirror. It will be an infrared telescope, and because infrared is heat radiation, we have to cool the telescope down to temperatures of 225 degrees below 0 Celsius. In comparison, Hubble is a room temperature telescope. When the astronauts go up to do the servicing mission, we don't want the astronauts freezing onto a cold telescope. So by working in the infrared and by gathering more light together, the Webb will be able to see the first galaxies that formed in the very early universe, maybe about 250 million years after the Big Bang. So if you would like to learn more about the James Webb Space Telescope, go to our website at jwst.nasa.gov.